purpose of this project, through the role as a university consultant, was to use historical data to make recommendations to universities about how they could improve the graduation rate. To accomplish this, descriptive and exploratory data analysis was performed to develop a multiple linear regression model for the purpose of predicting college graduation rates. Throughout this process, the model viability was assessed by analyzing important multiple regression assumptions for the data through residual and normal probability plots. The model strength was then emphasized by referencing the R-squared and adjusted R-squared values. The model significance was then investigated by testing an associated hypothesis. And lastly, the overall model usefulness and recommendations for future action were discussed. So looking at the RStudio window, let's first go ahead and load data into the workspace. So in this project, all steps of the data analysis were performed using RStudio. Through exploratory analysis, scatter plots were rendered for several combinations of predictor variables to visualize trends with the graduation rate before identifying three quantitative predictors, namely the count of faculty with PhDs, student-faculty ratio, and out-of-state tuition, to incorporate into the model. So we see our scatter plots here. We could see that from the first scatter plot, we have a moderately strong linear association between, or monotonic association between our graduation rate and PhD count. And the converse can be seen here between the graduation rate percentage, the student-faculty ratio, and then an even stronger positive correlation between our graduation rate percentage and out-of-state tuition. So these are the three predictors that were chosen to incorporate into the model. So let's go ahead and fit a multiple linear regression model to the data and look at the model results. So we have the following model statistics. We can see from the results that the out-of-state tuition and PhD count make significant contributions to the model through large t-values, while the student-faculty ratio is not an important predictor of graduation rate. However, before we can confirm the usefulness of the predictors and make recommendations, we need to check important assumptions about the data. So in referencing the scatter plots of the predictors against the graduation rate again, so we can see from the plots that they all satisfy the linear relationships or approximately straight relationship needed for a multiple linear regression model, and thus also satisfy the linearity assumption. In checking the independence assumption, although no conclusion can be made that the data are completely independent or that they are sampled randomly from a fixed population, we can make this assumption that they are independent, namely that the characteristics across colleges did not influence each other. So for the purpose of this regression model, the independence assumption does hold true. Lastly, the normality assumption and equal variance assumptions must be checked to ensure usefulness of the model. So if we go ahead and plot the residuals against the predicted values, so we can see here that there's no definitive relationship between the residuals and the predicted values, right? There's approximately equal spread. There's a little bit of tapering from smaller to larger values of the model or predicted values, but this tapering isn't significant enough to consider any sort of, or warrant any sort of violation in the equal variance assumption. Now if we go ahead and look at the normal probability plot to analyze the normality assumption, we can see that the relationship is mostly straight. The data doesn't deviate much from the normal distribution. So therefore we can make a conclusion that the normality assumption is met. Thus, all the assumptions that we've checked to make use of the linear multiple regression model have been met, and so the model is appropriate and can be used to model the data and thus make recommendations about future actions. So if you reference the model result summary again, the results display the test statistics and p-values that are the outcome of hypothesis tests to test the significance of the predictor coefficients in the overall model. So looking at the overall model results, we see a very large F statistic value of 130 and degree of freedom of 773, representing a large sample size, which adds more strength to the model. So when coupled with a very small p-value of 2e to the negative 16, this gives us sufficient evidence to reject the null hypothesis at a level of confidence of 99%, over 99%, conclude that the predictors collectively do make a useful contribution to the model. Now, if we shift our focus to the individual coefficients, we can see that the p-values for the PhD count and the out-of-state tuition are very small, giving us evidence to reject the null hypothesis for these coefficients and conclude that these two predictors make a very useful contribution to the model, while the student-faculty ratio does not. Now, the percentage of variability of the response variable is explained by the R-squared value. R-squared value of the model is 33.5%, meaning that 33.5% of the variation in the graduation rate is accounted for by the predictors in the regression model. This can be deemed a moderate relationship between the graduation rate and its predictors. Normally, this would be considered a weaker relationship. However, considering the large sample size with a degree of freedom of 773, as well as the p-value for the overall model, that adds more weight to the R-squared value, and thus this can be treated as a moderate relationship. So in conclusion, the model is determined to be of moderate usefulness in predicting university graduation rates, with the PhD count and out-of-state tuition being significant predictors while accounting for effects made to the student-faculty ratio, a weaker predictor. Although the combination of explanatory variables have a significant impact on the model results, in other words, the overall model is significant at over a 99% level of confidence using a hypothesis test, an R-squared value of 33.5% weakens the usefulness of the model, indicating a moderately strong relationship, and that much of the variability in the response variable was not accounted for by the predictors. My recommendation to the university as a consultant would be to make internal academic changes such as improving the rigor of academic programs and/or lowering the acceptance rate to offset the cost of introducing higher out-of-state tuition rates that many private universities with high graduation rates have imposed. In addition, I'd recommend increasing the number of faculty members with PhDs, as the quantity is positively correlated with the graduation rate. I do not have any recommendations regarding the student-faculty ratio, as it does not appear to have any distinct trend with graduation rate. Now, a moderately strong R-squared value introduces a need for future work to improve the usefulness of the model, as a majority of the variation in the model is not currently explained by the included predictors. Recommendations for future action would be to adjust the combination of predictors incorporated into the model by considering other variables such as acceptance rate, undergraduate to graduate ratio, and private versus public university that were not studied due to time constraints on the project.